IBESS Biodiversity Conservation Part 3 will focus on species extinction and how people identify species at risk of extinction. The essential ideas are: environmental change gives new challenges to species, which drives the evolution of diversity, but there have been major mass extinction events in the geological past. While global biodiversity is difficult to quantify, it is decreasing rapidly due to human activity. Classification of species conservation status can provide a useful tool in the conservation of biodiversity. Here is the outline for the biodiversity conservation movies. Use this slide to find the movie you need for review purposes. This movie is focused here. As I've mentioned previously in movies 1 and 2 of this series, species diversity has generally increased over time. Natural selection, working in combination with changing environments over long periods of time, has been responsible for the general increase in the world's diversity. But there have been 5 great extinctions. Here, 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 and here. The prevailing theory has meteor impacts as the cause of each of these extinctions. Interestingly, people are now talking of a 6th extinction, but the 6th extinction is not due to a meteor. It's due to the impact of people on Earth, the negative impact of people on the success of species. Here are the first 2 IB syllabus statements to kick off this movie, outline the factors that have resulted in mass extinctions, and discuss the causes of mass extinction. It's thought that the 5 great extinctions resulted from meteorite impact. The impact significantly reduced diversity in the short term, but with a changed environment, speciation resumed and diversity roared back. In this image, you can see a meteorite crater on the Earth in Arizona, in the United States, here on the Moon, and the impact of a meteorite that fell in Siberia in the early 1900s. In the same way that meteor strikes change the environment, thus altering the course of evolution, volcanic eruptions have also influenced evolution and increased biodiversity. Volcanic activity is most extreme at the edges of the world's plates. The solid crustal material floats on a molten layer of material just below, and at the plate boundaries, particularly convergent boundaries, where the plates bump into one another, the frictional forces result in volcanoes. Tectonic plate movements have influenced evolution and increased biodiversity. I've covered the influence of plate movement on evolution and biodiversity in Part 2, the last movie. Review Part 2 as necessary to understand the importance of plate movement on the evolution of species. Climatic change, including ice ages, has influenced evolution and increased biodiversity. This graph displays temperature fluctuation over long periods of time. With environmental change, such as the advance and retreat of glaciers, comes pressure on species to adapt. New species are formed. Evolution occurs. Climatic change, including drought, has influenced evolution and increased biodiversity. Species must adapt to changing environments. Environmental change puts pressure on species to adapt. This results in speciation, the formation of new species. Evolution occurs. Interestingly enough, humans are changing the environment, but we're changing the environment so fast that the rate of extinction is greater than the rate of speciation. The current rates of species loss are far greater now than in the recent past, and some suggest we are in the midst of a 6th great extinction caused by the activities of people. Let's look more deeply into the current estimates of number of species and past and present rates of extinction. Remember, scientists have classified approximately 2 million species, but we estimate that there might be 30 million, maybe more species on Earth. I'll let you review the mechanism of natural selection that changes the number of different species on Earth, that alters the biodiversity on Earth. All of natural selection was the subject of movie Part 2. But I'd like to move on to ask, how do we estimate the number of species on Earth? Dr. Terry Irwin worked in the Amazonian rainforest in an attempt to answer the question of how many species are out there. He fogged sections of the forest with an insecticide and identified everything known. What he found was that 80% of the species were unknown, new to science. He compared the number known against the number unknown and extrapolated, and based on mathematical modeling, he generated an estimate of 30 million different species on Earth. As you consider the techniques used by Terry Irwin, including the ethical aspects of his work, it's important that you think rigorously around this IB syllabus statement. Discuss current estimates of number of species. Realize that we use mathematical models, but they're influenced by classification issues. We need expertise when making decisions on what's new and what's not. As well, in the discussion, remember that extinction is ongoing, and new species are continually forming. Furthering the discussion, our understanding of how many species exist on Earth is further influenced by a lack of finance for scientific research, with habitats and groups of organisms being significantly under-recorded because some species are very small and hard to find. Some species live in remote habitats, deep ocean, deep soil, or high canopies. And it's a huge effort to catalog all the species. Huge quantities of time and money are needed. Now let's shift our attention to extinction. Extinction estimates prior to people were 1 extinction per 1 million species per year. This is 1/10,000%. Estimates today, and these are considered conservative, are 1/100% or 1%, which is 100 to 10,000 times greater than the background rates seen here. If the extinction rate is 1%, then 20% of the world's species could be gone by 2030. Recovery will take millions of years. And this is the thinking behind the so-called 6th Great Extinction. The IUCN has reported on extinctions of mammals and birds since 1500. They assessed 100% of the known species and found that the number that had gone extinct as compared to what was known generated extinction rates of 100%. These values right here are 100 times greater than background rates of extinction. The IUCN estimated the percent of various types of animals threatened with extinction due to human activities. 34% of fish are threatened, 25% of mammals, 20% of reptiles, 14% of plants, and 12% of birds. Now let's combine extinction rates with estimates of the number of species on Earth. If we apply an extinction rate of 0.1%, which is 1,000 times more than background, to an estimate of 5 million species on Earth, then 5,000 species will go extinct in 1 year. If we apply an extinction rate of 0.1%, which is 1,000 times the background, to an estimate of 14 million species on Earth, then 14,000 will go extinct in 1 year. If we apply this extinction rate to an estimate of 50 million different species, then 50,000 will go extinct next year. And IUCN data suggests that the number of threatened species is increasing in recent years. And in all of this, remember that documenting extinction is not easy. Extinction takes a long time. Exactly when is the last organism of its kind no longer living? And we've only identified 2 million species out of how many species? And what do we know about those that have not been identified? And remember that extinction is a very local phenomenon. It's very difficult to verify extinction. So let's shift our focus to a new IB syllabus statement. Describe and explain the factors that may make a species more or less prone to extinction. These are the factors that are used to determine conservation status of a species. A low reproductive rate, typical of the K-strategist, makes a species more prone to extinction. Species must be able to reproduce to survive. Low rates of reproduction make survival more difficult in the face of rapid environmental change. A specialized niche makes a species more prone to extinction. The panda feeds almost entirely on bamboo. If the bamboo habitat is threatened, so is the panda. A species with a narrow distribution or a rare species makes it more prone to extinction. The lemur seen here is native to Madagascar, nowhere else. Environmental change in Madagascar threatens the survival of the lemur. A requirement for a large territory makes a species more prone to extinction. As humans take more and more habitat for their own needs, species that require large habitats are increasingly threatened. Species with fixed migratory patterns rely on two different habitats for success. This makes migratory species prone to extinction because if either habitat of the two is disrupted, the species is at risk. Ground nesting species are prone to extinction because their eggs are more vulnerable to predators. This is a particular issue when non-native species arrive, ready to eat anything they can get hold of. Feeding at a high trophic level makes a species more prone to extinction. Species high up on the food chain are dependent on multiple trophic levels below. They also tend to be rare. Think about a pyramid of numbers. And they are prone to biomagnification, as non-degradable toxins increase in concentration up the food chain. Here is the first of two tables that list the factors that make species prone to extinction. In this table, I have identified the biological factors that increase the probability of extinction. Take note. I'll let you study this slide on your own. Here is the second table listing the biological factors that make a species prone to extinction. Study this slide on your own, but think carefully. These are the biological factors. The next slide teases out the non-biological factors. Here are the non-biological factors that make a species prone to extinction. I've covered the first three with imagery in the previous slides, but at the bottom I've added two more. The quality of the habitat is important because if people find something worth exploiting in a location, this puts the species in that location at risk. And many species are commercially valuable as food sources, and people have driven many species to the brink of extinction to produce food. As well, if people find some part of an animal of interest, such as a tusk, horn, or shell, they will exploit that species and put its survival at risk. Animals are often hunted for parts that are seen as valuable by people. Sometimes the animal provides food, but often the valuable part is nothing more than something seen as culturally interesting. The interest in ivory is nothing more than cultural, yet its economic value has driven elephants to the brink of extinction. Can we change culture? Rhino horn is coveted in the Middle East as a cultural object. Thus, the cultural interest and economic value of the horn has driven rhinos to the brink of extinction. Rhino horn is used to make dagger handles. One possible solution to the potential extinction of rhinos would be to cut the horn off of living animals to make them less attractive to poachers. Tiger's skin and bones are of cultural interest to people. A cultural interest in these items fuels an economic system of supply and demand. As a result, tigers are highly endangered. E.O. Wilson, one of Harvard's most famous evolutionists, once said in a wry manner that the species most threatened with extinction are big, slow, and tasty. The IUCN Red List puts species into categories based on estimates of how threatened the species are. The Red List categories are extinct, critically endangered, endangered, and vulnerable. These three are of the greatest importance to conservationists. The basis for estimating how threatened a species might be comes from three pieces of data: a reduction in the population size greater than a certain percentage over the last 10 years with estimates of continued decline, population size estimated to be fewer than X number of mature individuals, and an estimate of the geographic range in the form of the extent of occurrence with estimates of decline. So, red list status is based on rate of population change, actual size of the population, and thirdly, size of the habitat with rates of change. Let me provide examples of species in each of the red list categories. Extinct is defined as no reasonable doubt that the last individual has died. The passenger pigeon is extinct. The dodo bird went extinct at some point in the 1600s. The exact date is not known because of the difficulties in recording extinctions. Many factors contributed to the extinction of the dodo bird. It was rare, with a limited distribution, Mauritius only. It was a food supply for sailors. It was easy to kill as a flightless bird. An invasive species ate the dodo eggs. The dodo was a ground-nesting bird, so the eggs were easily taken by rats, pigs, and monkeys. Critically endangered is defined as having an extremely high risk of extinction in the wild. The mountain gorilla is critically endangered because of one or more of these three factors: a reduction in population size of more than 90% over the last 10 years, a geographic range less than 100 square kilometers, and a population size numbering fewer than 250 mature individuals with continuing decline. The orangutan is critically endangered because of habitat destruction. The forests native to the orangutan are under threat due to the demand for logs, for wood, and lumber. The leatherback turtle is critically endangered. Nesting has declined 70 to 80% over the last 10 years. The black rhinoceros is critically endangered due to habitat loss. You can see how limited its distribution is today and how widespread it was just 300 years ago. Habitat loss and poaching has pushed the rhino to the brink of extinction. Endangered red list status is defined as having a very high risk of extinction in the wild. If one or more of the following describes a species, it will be endangered: reduction in population size of greater than 70% over the last 10 years, a geographic range less than 500 square kilometers, and a population size numbering fewer than 2,500 mature individuals with continuing decline. The Asian elephant is endangered. In this diagram, you can see the former range of the Asian elephant in purple and the current range in red. Habitat loss has resulted in an endangered status for the Asian elephant. The tiger is endangered. You can see its former range in purple and its current range in red. Habitat loss and poaching have resulted in the tiger as having an endangered status on the IUCN Red List. Vulnerable is the next red list category, and it's defined as having a high risk of extinction in the wild. The factors that would result in a species being classified as vulnerable are a reduction in population size of greater than 50% over the last 10 years, geographic range of less than 20,000 square kilometers, and a population size numbering fewer than 10,000 mature individuals with continuing decline. The polar bear is classified as vulnerable on the IUCN Red List. The African elephant is classified as vulnerable on the Red List. You can see the extent of its current range in red as compared to its earlier range in purple. The cheetah is classified as vulnerable on the IUCN Red List. Genetic inbreeding has resulted in hereditary difficulties for the cheetah populations of Africa. The hippopotamus is classified as vulnerable on the IUCN Red List. A species classified as least concern would be a species that is evaluated against the criteria and does not qualify for critically endangered, endangered, or vulnerable. The gray wolf is classified as being of least concern. The status of the gray wolf has changed over time. Its status has improved from endangered to least concern. Red list status is determined by trends in population size, the estimated population size, changes in habitat availability, and possibly genetic factors. There are 16,000 species on the IUCN Red List. In the next part of this series, we will examine the human activities that cause species extinctions. The impact of humans on species will be covered in the next 2 movies, taking each of the 5 issues that you see here and providing some explanation. These issues, habitat destruction, invasive species, human population growth, pollution, and the overharvesting and overhunting of species, represent the large environmental issues driving species to extinction. The HIPPO acronym is easy to remember. And that brings us to the end of IB ESS Biodiversity and Conservation Part 3.